Today, I've got 50 tips and tricks if you're into 3D printing. Let's begin. If you print with composites or flexibles, chances are they're going to stick to the standard PEI coated plate and potentially damage the print surface. When I was printing on my Qidi Plus 4 comparing some abrasive materials in our composite showdown, this exact thing happened. This ASA CF stuck hard to the standard powder coated PEI plate and it ruined it. Luckily, Qidi sent me over this new smooth plate which is meant for these kinds of materials, and it's been excellent. Also, if you're looking for a universal solution for loads of other machines, these blue plates from BIQU are my favorite. We use them on tons of our machines. So having the correct plate is super important. But what if you forget to swap it out before you print? If you're like me and you find yourself printing TPU on a textured plate accidentally, there is a super easy way to release those flexible prints from that standard PEI plate. I say it's a super easy way. There's a method that makes it easier, but it's still not like super easy. All you need to do is drizzle some isopropyl alcohol onto the base of that model. If you can, get a little bit of the model released at one of the edges, and the IPA will work its way under the smallest gaps to help that part release. This was actually a huge game changer for me. Speaking of flexible filaments, if you're using something like this TPU Air from Qidi, you can vary the hardness by changing the temperature that it's printed at. But if you're doing this, you also need to alter the flow rate to ensure the product has room to expand. Foaming filaments like this one bubble up more when they're printed at a higher temperature, but if you don't lower the flow rate, then there's no room for that foaming to occur, so you're not really going to see a change. Refer to the manufacturer's site for more information on that one. And while we're at it, check out this VarioSure TPU from BIQU. It prints at 90A hardness initially, but when it's finished, the hardness becomes a bit softer, more like a 75A. There's a lot of printers that would struggle to print something soft like a 75A or even an 85A, so this material offers quite an advantage. This is a great way to achieve a much softer print for things like shoes and stuff without the need for a printer specifically set up for super floppy filament. That's very cool. I like that. Now, if you have a more basic enclosed printer like the Anycubic Cobra S1, chances are it doesn't do active chamber temperature management. If that's the case, a lot of these manufacturers recommend that you keep the door open to keep the heat from the hot end and the heat bed from creeping up the nozzle. If too much heat builds up when using low temp materials like PLA, you may just get jams from the material softening too much to even keep printing. In the case of the Qidi Q2, the top glass is designed to be slid back and secured in the open position for this very reason. Now you can all comment how you keep the door on your bamboos closed and you've never had an issue and blah 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 blah. Alternatively, if you do have this issue but you don't want to worry about keeping your chamber vented somehow, you can try your luck with these BIQU blue plates that we spoke about before. Instead of the smoother ones that are aimed at composites, this dark blue one's meant for PLA and PETG, which are the low temp materials that suffer from this issue anyway. The advantage here is the bed temps needed for these plates is much lower, which means less heat buildup in your chamber and a lower risk of clogging the nozzle. There's also a power consumption advantage offered by running cooler plates, so have a look at the link below and see if this is right for you. If you're like me and you use one of these multicolor systems, chances are you may need to feed an incompatible spool into your printer at some point. In the case of TPU on the A series of printers from Bamboo, you're unable to feed the TPU through the AMS light. I personally don't like reaching around the back of my machine and fighting the mess of tubing and stuff from the AMS light setup, so to solve this, I simply feed the filament through this pass-through block that I made, and I use the AMS spoke as the spool holder. This model's available in the description if you want to check it out as well. Dry your filament. There's lots of filaments like PETG or TPU that are hygroscopic. That means they soak up moisture that needs to be baked out before printing. We've spoken about various dryers like the Creality Space Pi and the Filapartner from ChiTu Systems for this very reason. This is what this pink Overture TPU looks like when printing on standard settings using the Elegoo Centauri carbon. After drying it with the poly dryer for the recommended amount of time and reprinting, it looks much better. This spool had obviously soaked up a lot of moisture. But also, if you dry your filament and that still doesn't help the quality, likely there is a tuning issue. I thought this same pink TPU was wet, but in reality, the printer's default TPU profile isn't quite dialed in. To verify something like this, try printing the same thing on a different machine. This will tell you if you need to chase the profile tuning or if you do, in fact, need to look at your material. In this case, I printed the same model on my Bamboo A1 Mini and it came out super clean compared to how it turned out on the Centauri carbon. If you need to print a few different models, but you aren't going to be around to switch the plates and restart the machine, try using the Print by Object setting. This will allow the printer to complete an object, change colors if necessary, and then move on to another object. And just like that, you're able to automate printing several different objects inside of the same print. Alternatively, it can be advantageous to print multiple objects using the standard by layer option. If you're using a gradient filament like this matte gradient from Polymaker and you want to make the color change happen more rapidly, go ahead and fill that plate, people. By increasing the amount of filament used in each layer, you get to the next color much sooner. This is a great way to get the whole range of color in a single model no matter what size it is. But let's say you've got a print and the time estimation's just a little bit too long for you. Let's say we want to speed that sucker up. If you don't want to crank up the speed and acceleration values, try changing up the number of walls, infill, or layer height. By changing these values, you're often able to compromise in one area, such as strength or resolution, in order to achieve a faster speed. This is super helpful if you're trying to prototype and iterate before printing the final part in its final iteration. And speaking of infill patterns, some infills are optimized for strength in certain directions, while others are more tuned for speed. If your infill has a lot of straight lines, such as grid or line even, you aren't going to see any speed penalty. That typically comes at the cost of part strength. Infills like honeycomb tend to take a little bit longer, but tend to be stronger in general. The best compromise between speed and strength usually comes with the 3D infill patterns like cubic or gyroid. These result in a much more even distribution of force in all directions since the infill creates 3D structures inside of the model. But can infill help weaken your part? You can use infill patterns to tune in characteristics of your print other than the strength. If you're using TPU and you want maximum flexibility, for example, use the concentric or Archimedean chords infill to provide the reliable structure that doesn't add rigidity. Although if you're looking for maximum squish, usually the best option is going to be a zero infill. As long as your model can handle the overhangs or at least cover the surface artifacts caused by having no infill, this one's the way to go. Now if you do want to do some tuning and dial in the performance of your materials, you can use Orca Slicer's built-in calibration tool. These models choose a parameter such as temperature, for example, and vary it across the duration of the print. Each step on this temperature tower shows the immediate quality changes that occur when stepping the temperature up or down. That way you can examine the print and determine what setting's best for your application by comparing it directly to the next setting on the tower. What about super smooth top layers? What can we do to minimize or eliminate the artifacts that you often find on the top of a print? Well, if you weren't aware, ironing is a setting that can be used to smooth out the top layers of a print. It commands the printer to drag the nozzle over the top layer while extruding the tiniest bit of filament at the same time. This dragging over the previous layer and extruding filament leads to very tiny gaps in the extrusions being filled while the hot nozzle kind of melts everything together. When tuned correctly, the result is a nice, smooth, consistent top layer. Hey, here's a tip for you. Why don't you check out our second channel? It's called You Like That.
You like that? Yeah, you like that.
And we do challenge videos where contestants go head-to-head in battles for printing the fastest, or printing the worst, or all sorts of crazy things. We've got a couple of videos out now, and a couple of videos are going to be coming out soon. Head over there, check it out. Now moving on to some upgrades. If you're looking to get into a budget Core XY Bamboo machine, then the P-Series from Bamboo offers some excellent choices. Especially if you're looking at the older series of Bamboo machines that don't come with hardened internals straight off the bat, you're not going to be able to print abrasives unless you perform some upgrades. The Panda line from Big Tree BIQU solves this problem for much cheaper than the cost of upgrading in some cases. Specific for our P1S, they've got everything you need to upgrade your printer so it can print whatever abrasive composites you're wanting to print. Moreover, if you're trying to add hardened gears to your P1S toolhead, consider grabbing the Panda Jetpack kit as well. This is a lightened faceplate that not only looks cool, but it also provides more even part cooling from the fan duct at the nozzle. But most importantly, this weight savings allows you to add those heavy hardened gears to your toolhead without adding any weight to the whole system when they're all used together. The faceplate's lighter, the gears are heavier, that means your printer can operate inside of the same parameters it was designed to operate inside of. But what if you want to do something with your A-series printer? Well, the Panda line has you covered again. The Panda Claw, for example, is a drop-in upgrade that'll have you printing abrasives in no time. BIQU has a whole line of A1 and A1 Mini upgrades available, so check them out if that sounds interesting to you. We just got sent some new ones, so there's going to be some videos coming out on that soon. It's nice to see that even if you are using a cheaper bed slinging option from a company like Bamboo that's fairly locked down, these aftermarket upgrades are available and they provide even more versatility to your machine. But why would you want to print abrasive materials on an open machine like the Bamboo A1? Well, in the vein of filaments that try and tear your printer components apart, did you know that glow-in-the-dark filaments are abrasive? If you don't have a hardened steel nozzle as well as hardened internals, you run the risk of wearing out these components prematurely. At best, this can lead to printing artifacts and, at worst, general machine failure. So be aware of the risks when you run those pretty bright plastics through your stock setup. Also, you probably shouldn't run abrasive materials through your multicolor unit. In general, the feeder gears in these are not rated for abrasive materials. That means no more glow-in-the-dark filament in your AMS, no glass fiber ABS in your ACE, and likely no carbon fiber nylon inside of your CFS. That said, the Qidi box is the only multicolor unit currently available that is abrasive ready. So luckily, there's no need to use an external spool holder for those fiber reinforced filaments in the Qidi Q2 or the Plus 4. Now finishing up with the abrasive materials, sometimes you've got a project that needs something a bit higher performance than what you might have access to. And this video's sponsor, PCBWay, can help you out. In the cases where you don't have access to the material, the machine, or the manufacturing process, CNC milling, PCB manufacturing, whatever it is, now you've got the ability at your fingertips. For me personally, I don't like resin machines and I have no plans to get into using resin printers. But if I had a project that required that level of resolution that you could only get from a resin machine, you better believe I'd be going to PCBWay and not buying my own. So check the link in the description and get your projects done, you people. Now let's talk about something that we're seeing more commonly today, multicolor printing. If you're trying to print multicolor but you're worried about the waste, experiment with your prime tower and purge settings. In some cases, the purge multiplier can be set all the way to 0. From there, you just need to make the color change and the bleed that happens during that color change work in your favor. This will greatly reduce the wasted material as well as the purge time for that print. And you might come up with a cool effect on your model that you wouldn't have otherwise had. As for the prime tower, you can take this out completely if you're really trying to eliminate the waste or print time. In my experience, however, this is worth keeping around. The prime tower is there to prepare the nozzle to print on the primary objects. That means the filament's pressurized and primed inside of the nozzle, ready to print without any artifacts, but the tower also acts as a sacrificial piece that collects any stray filament. If there's some nozzle ooze hanging around, it'll get caught on the tower instead of the thing that you're trying to print. It's totally worth the extra filament in my opinion. Another strategy that's often overlooked when talking about waste reduction is strategically coloring your models. For example, if you can orient your model to keep your colorization in plane with the layer lines, you can reduce the number of color changes that need to occur. Each different layer that needs a color change means added waste and added time for your print. That's why if the colorization can happen at layer changes or in plane, that's hugely helpful for both the print time and the material waste. Otherwise, if there's a color change that needs to happen throughout the entire height range of your model, you can still make the most of it. Since each layer is performing a color change anyway, now's the time to add that same color all over the rest of the model. You won't be penalized in terms of waste because once again, the color change is already happening for that layer. Now you're just maximizing the value of each color change by coloring other features inside of that same layer. Now, with that same idea in mind, the same goes for multiple models. In order to get maximum value from your color changes, it often makes sense to print a whole plate of models instead of just a single multicolor model. Once again, these color changes are already happening for one model, and there isn't too much that can be done about it. So why not make the most of that fact? By printing 100 of the same multicolor models on a single plate, the waste penalty is now spread across all of those pieces, and that increases the overall value of each piece. Now, let's move on to something that I absolutely hate. Support material. If you're needing to print something that's oriented in such a way that there's unsupported overhangs, you're going to need support material. The standard style tower and then the tree style support. Be sure to have a look at the various settings to ensure you're using the correct style for your application. But for me, I always use the tree style. I tend to have more luck removing that style, and there's generally a better surface finish just in my experience. If you want a little bit of extra help when removing your support material, you can look into some tools such as this ultrasonic cutter from Hanboost. It vibrates its blades super fast to help make super clean and precise cuts. We did a video on this thing and it is pretty cool. It doesn't automatically make everything 1,000,000% faster, but it does help in the situations that it's designed for. Even if you have shaky hands like me. Shaky hands like me. Although there are other ways to deal with support material. For starters, why not try designing your model in such a way that it doesn't even need supports? If you have an unsupported overhang, see if the situation would allow you to build up to that material using a chamfer or something similar. Oftentimes, changing how you're thinking about designing for 3D printing can minimize or completely eliminate those pesky overhangs altogether. Another way to overcome the overhang issue is looking at your print orientation. Generally, you want a decent sized contact patch on the print bed, but it doesn't always need to be the bottom face or even the biggest face of your model. If you can tilt your model on an angle, for example, many of the unsupported overhangs can become printable. I like this method especially because it allows for a more consistent finish. Instead of one whole side of your model having the bed surface finish while the rest simply shows layer lines, the greater majority of the model now has the same finish. But what if you do find yourself in a position where you need support material? There's no way around it. Well, another great option is to design the support material yourself. This way you've got a much more precise handle on what pieces are being supported. Also, this will allow you to ensure your material is easily removed from that model, instead of risking any surface artifacts from the removal of standard support generation. Most importantly, this ensures your model is printable on any machine, using any settings with any slicer. No need to remember your support settings, or to save a specific 3MF. Now, if you do end up turning on support settings, or messing with any settings in general, this is where a 3MF can absolutely save your hard work. Contrary to an STL, the 3MF allows you to save additional information aside from simply the 3D model or the geometry. Any slicer settings like supports, infill density, perimeters, or layer thickness, all that's going to be retained. Also, this allows you to save your colorization of the model if you're printing a multicolor print, which is likely the thing that this format is most commonly used for today. But back to support material for 1 second. Let's say you're in a situation where your model needs supported like a lot. Another method you can employ is the use of two different materials. Looking at PLA or PETG, for example, these are two plastics that don't stick to one another. This can be used to your advantage if you want easy support removal. Just set your support gap to 0 so the object material is printed directly onto the support material for a more reliable result. Additionally, there's purpose-built support materials that can be used in the same way. These are materials that are meant specifically to break away from standard printing filaments to ensure a nice supported surface. This has the added benefit of a nice removal experience. There are specific materials designed for the filament that you're using, so have a look to see which is best for your filament. And while you're at it, sure, you can set your support material to one type of plastic and set your model material to another type of plastic if you want to, but depending on your model and how much support you need, doing the entire support in a different material can be very wasteful, especially if you're using a single nozzle machine that requires a purge in between the material changes. For these situations, you should probably investigate using the support material only at the support interface. This will swap that material only at the layers that are touching the model instead of the entire support tree. That means fewer purges, fewer changes of material, generally a faster print, and less waste. And the final note regarding support is probably the most important. It's the fact that you can support this channel by checking out our Patreon. It's only $2 a month, and your support over there helps us on our quest to do this full time. You also get discounts at QOprints.com. Sometimes I give out early access to videos and stuff. Maybe there's behind the scenes, maybe there'll be Q&As. We'll be building it out as we go. But it's only $2, so like you're not getting a crazy value. You're getting a value proportional to the amount that you're paying, which you're not paying very much, so I'm just not selling this very well. I don't know, check it out or grab some merch at QOprints.com maybe. Now let's take a second and talk about a few different filaments, shall we? For starters, PLA. What is it? What's it good for? Well, most of us know that PLA is the go-to for parts that need to print well and look good. It's generally an affordable material and it's more or less the standard. But what's often overlooked is the structural benefit of PLA. Though this material is not very heat resistant and it isn't known for its mechanical properties, the fact is it's one of the more rigid materials available. So if you're looking to make a bracket for use indoors, it doesn't necessarily need to be made from carbon fiber nylon just because it's going to be load bearing. Often PLA is super sufficient. But once again, in the cases where PLA doesn't quite stand up, there are other options available. For use in outdoor applications, consider this HT PLA from Polymaker. We reviewed this stuff recently and I was pretty impressed with its ability to stand up to heat. It's very commonly known as a huge weakness for standard PLA, and this HT PLA does not disappoint. I've had this watering can left out in the sun on more than one occasion since printing it, and there's no indication of any damage or warping. But be aware, this heat resistance comes at a strength penalty. So keep that in mind when you're choosing your material to accomplish your tasks. Now speaking about outdoor use plastics, often people like to jump straight to ABS or ASA. These are the styrene-based filaments, and they're usually the go-to for anything that's subject to a harsher environment. ASA in particular prints well and is fairly chemical resistant in a lot of applications. The trade-off here is the fact that both of these materials, ABS and ASA, require a heated chamber to print, as they're very prone to warping. Adding to that the fact that they give off potentially harmful gases or particulate when printed, be sure you're taking the necessary precautions. But if you're asking me, I prefer PETG for like 90% of my functional prints. As a jack-of-all-trades kind of material, it does it all. Interlayer adhesion and heat resistance is much better than PLA. Indoor use, outdoor use, its general toughness and strength is suitable for quite the majority of applications. It prints very easily and is common, which makes it affordable. It's available in whatever color or finish you choose, and there aren't really any specific printing requirements needed other than a nozzle that heats to at least 230 or so. Even though it's super common and a lot of people use it, I still feel like it's a little bit slept on. And finally, TPU. There's tons of different varieties and even more coming out by the day. These flexible materials are great for making compliant mechanisms, but they also offer a bit more than simple flexibility. For example, adding TPU to your print can be a great way to insert a grippy feature at the bottom face of an item. Additionally, TPU is massively tough. Especially when printed at higher infill densities, TPU can be used to create a part that's incredibly strong. This is a bit counterintuitive because we all think of it for its squishiness, but it is something to consider. And while we're talking about using TPU, why not print PLA at the same time? Let's talk about the interlock settings available inside a Bamboo and Orca slicer. This setting and subsequent settings allow you to control how much interlock there is between two materials. So in the case of TPU and PLA, these two don't stick to one another. This can make printing difficult, but it can also provide an opportunity for the two portions of the final printed part to delaminate. By using the interlock setting, this effect can be avoided so your prints don't look like this. That's about as deep as I'm going to go into specific printing materials for this video, but be aware there are different variants available that offer different benefits. For example, PCTG is a great PETG upgrade depending on what your project calls for. Similarly, if you're looking at nylon for your project, investigate the difference between PA6 and PA12. Some of these materials, like this Fibron PET-GF, are made at a price point because not every project requires maximum strength. Using something like this instead of a nylon offers a much more affordable option that still retains incredible strength. Others are much more expensive but offer those mechanical advantages that are only available at that cost. Speaking of high performance materials, what's the deal with fiber reinforced materials anyway? Well, an easy way to add some rigidity, heat deflection, and general strength to your print is through the addition of these fiber composites. They're often short chopped glass fibers or carbon fibers that bond to the plastic that they're suspended inside of. They'll all point in the direction of the material flow, which is how the strength of the fiber becomes imparted on that extruded plastic. Depending on your application, this can be a simple way to achieve the level of strength or rigidity that you're needing. Now, the reason that we have glass fiber in some plastic and carbon fiber in other plastics is actually pretty simple. Glass fibers tend to cost less while still boasting similar mechanical properties as the carbon fibers. But it's cheaper and it often prints a little bit easier. However, if you are looking to get that extra juice for your super high performance plastic piece, the carbon fiber is the way to go. It's more expensive, but it's lighter, stiffer, and more heat resistant, which can translate to a better performing part. Sunlu's got an excellent line of composites that contain both, so consider checking that out. Now, as a final note regarding the fiber-filled filaments, there is one advantage that a lot of people don't talk about all that often. It's not the strength or the mechanical properties, it's actually the surface finish. In my experience, printing with these composites often leads to a great surface finish that's difficult to achieve otherwise. The rough texture makes the layer lines of the piece much more difficult to discern. There are a lot of cases where this can make your part look and feel a lot more premium, even though at the end of the day, it came off of a 3D printer inside of your house or office. This is something that's absolutely overlooked in my opinion. Functional stuff's great, but the aesthetic advantages here are huge. But let's say you don't want to use your expensive fiber reinforced filament every time you want a part to look super consistent and clean. What else can you do? Well, I'm glad you asked. Fuzzy skin, have you ever heard of it? It's my favorite. This is another setting that is an underused one in my opinion. The fuzzy skin makes the surface of your print textured, but there's loads of control available. If you're wanting a super drastic texture, or if you want a subtle fuzz happening, there's settings here that allow you to tune it to make it happen. The only thing that you do need to keep in mind is the fact that adding this texture will come at a print time penalty, especially as the texture becomes more pronounced throughout the print. As a side note, here's a little half tip to go with the fuzzy skin. Use the scattered seam setting. You don't need to worry about seam lines because you already have a texture on your print, and this makes it so that texture remains consistent. Finally, the last tip has to do with aesthetics as well. If you find yourself needing some new shirts, hats, or hoodies, you can go to keoprints.com and get them. Support our efforts to bring you content full time. Bye.